Hi, so my name is Prem Asim Jain and we are going to learn about threading in Java in this session. So basically, thread is the feature of Java which allows to achieve the multitasking of a Java program. So whenever you write a program, if you want that multiple threads can execute it so that the output is faster, the throughput is more, then you might implement these threading. So all these servers, JBoss server and other servers, they rely heavily on the threads. So instead of creating separate process, because processes are really heavy and threads are just part of the process. So you can think of a process is a hand and threads are your little fingers. So you can, if you can play well with your fingers in a harmony, you can get a nice music. But if you are not able to manage your fingers well on a keyboard, then you might get a noise. So controlling the threads is very important for a program to create harmony, proper output, or we can take the analogy of a nice music. So how this thread can be created basically, so there are essentially two ways. Basically it's the one way, second is the simpler way of it's more or less the same way, but technically yes, there are two ways. First is you can implement a runnable interface which does only have one method which is called as run. So whatever class which implements runnable method has a run method, so it has the capability of you have the capability of treating that class as a thread class, and then whatever you code wants to get it executed inside by the thread, we call it as the job, that can be put inside the run. So this is the first way of implementing an interface. Here we have implemented runnable interface, then we have a job here. For example, the very common scenario is copying and pasting. So if in Windows you try to copy from one folder to another and there are so many files, so if you will do one by one, then it will take time. If you can create 10 threads and each thread will go pick up a file and copy, so even though you have 100 files, but it would be very faster because there are multiple threads which are working. So we have taken an example here, public class, my multi-thread class, and then whatever class you have, you call it as a job. So job, since job class implements runnable interface, whatever task you give here, that can be executed by the multiple threads, something like this. So we can execute it real quick. So this is running. So the task, the basically the task can be run. So we see that we are seeing just couple of output here. Why? Because the third thread which we have created, it has not been started. So the point to note here is, unless you don't, the start is used to start the thread, but whatever task you put inside the run, that runs. So for a thread, two methods are important. First is run and second is start. Now if we will run it, you will see that each thread is trying to copy and paste it. So sequence is not that first they are not in sequence. So first thread copied a file and then it went to sleep. Another thread got the opportunity, it also copied file. And reason is why they Java made it, because whenever any resource get opportunity or a simple space, it goes and does its job instead of waiting on the other processes. So first process copied, second copied, and then first pasted, then third copied, then the remaining they did the job of pasting just to make it more efficient and faster. So this was the one way. Second is you can just do a extends thread. So here your thread just extended a thread, and inside that run is the basic piece of code which you want to get it executed. And then in the main method, we just created the thread. We also have given the name to the thread here, and then we just try to start, and as soon as you start, the execution starts. So this is a very basic thing about how we do create threads. Now we'll look into the next topic, which is the thread scheduler. So how thread scheduler work? Thread scheduler in Java is the part of Java virtual machine that decides which thread to run. There is no guarantee that which runnable thread will be chosen to run by the thread scheduler. Only one thread at a time can run in single process. The thread scheduler mainly uses primitive or time slicing scheduling to schedule these threads. So now let's go to next. There is a method which is called as sleep. So sleep is either the thread scheduler. Thread scheduler is nothing but you can think of it as a thread manager which decides which thread will run, which thread will wait, and other things. So here the sleep. So let's first go to the life cycle. So we see that thread scheduler will decide as soon as you start a thread, it goes to runnable state. From runnable, it can run, and then after running, it can go to the non-runnable or the blocked state. So thread scheduler's job is to operate this, that from new to runnable, runnable to running, and then once the job of the thread is done, it goes to terminated state. Otherwise it can go to the so there are methods to send it to the block state. First is sleep, second is block, third is wait, then there is lock, suspend, and there are several other methods. If we go to the basic object of Java, which is the core object, it also has the method which is notify all, and thread supported method. So each program or each object in Java inherently supports the threading basically. So now we'll see the example of the sleep, how sleep works basically. So we created a thread, and then instead of thread scheduler calling the sleep method, we called it as 500 milliseconds, which means half part of a second. And then it throws the interrupted exception. Sometime if there are some interruptions which are creating some trouble, then you can always catch it and print it. So later on you will get some information what exception occurred, why your program didn't run as expected. So now here is the question, can we start a thread twice? So we can just try starting a thread twice. So in this example, we have my thread which is extended by thread. So this thread internally implements the runnable interface. This is a thread class. It so you directly implement runnable, or you extend a class which is thread which indirectly implements the runnable. So it's almost the same thing, but the benefit of extending a thread is you get some default implementation and some of the utility methods of the thread class which can be used. And second thing is if you are extending some other class, then you cannot extend thread class itself, because Java does not support multiple inheritance. It supports multiple like not the class inheritance but the interface. So it can implement multiple interfaces. For example, you have runnable and serializable. So both can be implemented without a problem. But if you will try to extend two, then it will create the problem. For example, you have thread class, and then you would like to extend the object class or whatever other class. This does not allow. So this is an important point to be noted. Now we will try to invoke the same thread twice. So let's see what happens. We will run it now. So it will give you this red guy is called as exception. So why happened, what happened, we'll just try to learn. So exception in thread main, java.lang. Illegal thread state exception. So we have learned that a thread can be in one state at a time. It is not supposed to be in multiple states at the same time. So if a thread which is started, it cannot be started again basically, and that's how this exception is, talking to about. Then it is saying that it happened at the java.lang.thread.start. This is the file name and the line number. So this is framework file. However, this thread started from this guy. So we will see here. So once we started, it was cool. It has already started working and printing the first thread. Look, this was supposed to print it 5 times. So 4 times it print, but as soon as this thread, progressed a little bit, and next thread tried to start, and then the JVM realized it cannot happen. Then it threw the exception, and it has given you the information from where it has happened. So this is very useful. You can just click and see what is your program problematic code. This code is in your hand, but the above line is not in your hand. So this is implicitly the Java file, and 705 here, from here it threw the exception. Why? Because whenever, as soon as you try to do the start, this method is not invoked for the main thread or system group threads. So I'll also tell you about what are the groupings of the thread in some time. Set up by the VM. Any new functionality added to this method in the future may have to be added to the VM. A zero status value corresponds to new. So whenever a thread gets started, its value is not 0. It will become 1 or 2. Each state has a status number. So since it is not 0, then the exception has been thrown. So I'll capture the exception handling lecture or session separately, which will let you understand that how to create the panic in a program. Panic means if something is wrong which is happening, you need to terminate the program or change the execution path, so that expected thing happens. For example, in a banking program, if the balance is non-zero, for example, if the balance is 0, then you should not allow the user to draw the money. You should throw an exception. You can say null account exception or null money exception, something like that. Otherwise the program is not good if it is not creating exception or allowing anything to anybody without putting sufficient conditions or constraints in place. So that's how we learned that same thread cannot be started twice. And then we also learned about sleep method. How does the sleep method works? You just pass it to the milliseconds. What if we call run method directly instead of start? So this is another very interesting thing to learn here. Now what happens that any method, any object will have some method, and you can call it no doubt anyways. It would work fine. So if you try to call run, then it will do the normal execution, not in the multi-threaded way. So we can try this out. First we will try to comment these things out. Then we will try to run this. So nothing happens. Why? Because the thread has not been started. So thread has scheduler has not given it any sequence of running it. Now what we are going to do, we have object reference. One is T1 and T1 has run. You can also implement your own sleep method here, and you can also call the sleep as sleep. That's not a problem. This is your sleep method. and you can even call that. But please remember that this sleep method is not the actual thread sleep method. So what is the problem it is having? Okay, so this is the thread method. So this is now you can technically you have to create the object reference like this. Job is equal to job barabar new job. Now you have job. So you can call job.sleep. You can call job.run. Let's try to run. So this is just a normal object. This is not a thread object because we are not instantiating it against this runnable interface or whatever. That is why as soon as you try to run this, it won't go it. So this will run in sequence. Whatever number of instances you want to create, you can create, but this will not be beneficial as thread scheduler. Whenever it gets opportunity, it will allow any thread to go intermediately and do a job. This is sequential or a blocking. So I'll give you the example here. You have job 1, job 2, job 3. Job 1, job 2 and job 3. And if you will try to run this, it will just run in the sequence and print everything in the sequence. So you have job 2 and job 3. Let's try. So everything is in sequence. First it copied from A, then it pasted to, and then it slapped. So this is sequential. Let's say if there is some space between some time, some minute time wherein another thread could have utilized it. This is not happening. It is just waiting for one process to get finished, then another sequential. So how to make it utilize in multiple ways? So what we are going to do is we'll just put it like this. Then so here I'll give you the concept. Let's put it this way. So now we are trying to create the thread class called as T1, and the thread class has a constructor which takes the job. Thread. So this thread can take up a job. So what we created over here is we just created a job, and this job can be passed on to multiple threads over here. That's what we are trying to do, that we are creating multiple threads, T1, T2 and T3, and this is a job. So each thread can have the same job or can have the different jobs. That is fine. That's not a problem. So we will give same job to two threads and then another job to third thread. It is interchangeable. It's just that you have to clean some room of the house. So how you want to distribute? If we run it, nothing will happen. Why? Because we have not started the thread yet. So job has been created, job has been assigned to multiple threads. Now we will try to start each thread. So start will internally call the run method. So you don't have to, previously we were calling this and it was running in a sequence. Now it will run out of sequence. As soon as it get even the minute, second, it will go and run. So it might not be in a perfect order or sequence, but it will run all by itself. We can change it now. So 3 jobs, 3 threads we need to run now. So it messed up the sequence little bit, whatever, but this time the thing was faster. And why we were, it's very minute. These are three process, but let's say there are hundred or thousands of users which are trying to hit the Amazon web server, and then you will realize a huge difference if it is sequential versus if it is a unitask or multitask. So with threads it becomes multitask. So in parallel, two threads can also work, or while one is waiting another can take the space, but in sequential way it does not. So main thread, so this is the concept. If we call run method directly instead of start, it will do the as if it is just doing the normal execution of the program. Thread scheduler will not come in place. Now there is something which is called as the join method. So join method waits for a thread to die. In other words, it causes the currently running thread to stop execution until the thread joins with completes task. So we have created three threads over here. We have started one thread, and then we said thread one to join. So once the thread is started, join means until and unless this thread does not finishes execution, it will consume all the resources, and then other threads can join it. So we'll just try to run this. So your class type has to be this, and then your thread has to be this. Your thread has been created. Each thread is sleeping for a while, and then it is trying to print something. Let's try to run. So the interesting thing to notice here is first thing is in sequence, which means the thread first finished its execution first, and then the other threads, as soon as they got the opportunity, they did it. So you will find that let's say if this took 5 seconds, I'm just assuming 5 seconds to finish one thread, within that 5 seconds double work has been done. Another two threads did some time sharing and finished it. So it was faster. We'll run it again. Observe, it is going 1, 2, 3, 4, and the thread scheduler does not allow other threads to join until and unless this does not get finished. So this is how join works, and you can also give it a parameter that join means it. So this is how that I have three students, and I'll say first student has to work for some time. If he's not able to finish it, then other people can start. So first has I can give him or her some time. So let's say we have given 500 milliseconds, and I'm expecting that in 1000 milliseconds, first has to finish its job. If it is not able to finish within time, other can join him to help. 1, 2, and then other guys started basically after this. These are some other parameters. So join thread, sometime people first try to make sure that first high priority thread should finish, so that once it is finished and other thread helping threads can come after that. One thread will lay out the foundation and other threads can do. As in companies, the team lead, they will say team lead to finish one task. Once he accomplish that, then they distribute and I would say everybody to work in parallel once that first thing is done properly. Your class monitor in your schools basically, or your team lead here professionally in companies. So now we'll go and see get set name, get ID. So you can set the name for the thread. You can get ID. These are like really simple stuff. We'll not go through it. We'll just read them and bypass. So current thread. So there is which currently thread is running this. So there is a method in the thread which is called as current thread. This will give you the name. This is important, sometimes used very oftenly. So we'll try this so that you understand which thread is currently running. And you can give the thread names also, whatever name you want to give. So we'll say t1 dot set name. You can say MONNIT or monitor thread. And then other threads can be t2 set name normal student, and you can say t3 dot set name. This could be a dumb. It's dumb student. Dumb student, which does not understand anything. You have to repeat so many times. He doesn't pay attention to homework, something like that. So it could be. So he will take time. So first the monitor will finish everything. He will wait. Normal student then can grab. And at last the dumb student does it. Something like that. So just try running it. Now we say that monitor thread kicked in. Then normal student and the dumb student worked in parallel. Dumb student surprisingly finished before the normal student. So it can happen in threads basically. Whenever any gets the opportunity, thread scheduler puts it. Naming thread and current thread. So we already saw this, how to set the name and how to get the name for the thread. So priority of a thread. Now to set the priority. So this is interesting. Basically, there is a enum also which maps. So thread priority are usually from 1 to 10. So higher the number, more would be the priority. Priority are represented by a number between 1 and 10. Most cases, the thread scheduler schedules the threads according to their priority, known as preemptive scheduling, but it is not guaranteed. So we can try this guy out. Let's try to give priority to the dumb student as minimum. Thread dot int. So we can either give it the number, or there is a enum which is called as, and this would be static enum. So we'll say thread dot minimum priority. Normal student will get the normal priority. This guy has maximum priority. This guy has normal priority. And the last dumb guy has the. Now let's see if there is some change here. So since dumb student has the minimum priority, it is supposed to finish at the last. And the high priority guy is supposed to finish, the monitor thread, we call it as class monitor, is supposed to run first, basically, finish first. Now there is a fundamental concept which is called as daemon thread in Java. So daemon thread is a service provider thread. So whenever your program runs, there is in your program itself there is finalize method, and there are some other methods. So a system generates some service threads which executes in your program by default. For example, your garbage collection. So whenever you run your program, your main method runs your normal execution of the program, but the daemon thread comes and run your garbage collecting program, which cleans up the memory. So we'll learn more in detail in today's session itself about how garbage collection actually works, and then we'll understand about it. So this the daemon thread point to remember, it provides service to user thread. So there is system generated thread and there is user thread. So whatever I am running is user. I am a user. Whatever JVM runs is a system thread. System runs. It has no role in life. Then the service. So it provides services to the user thread for background supporting task. It has no role in life than to serve user thread. If user thread is gone, then the daemon thread is not required. It also goes away. So its life depends on the user thread. It is a very low priority thread. Why JVM terminates the daemon thread if there is no user thread? The sole purpose is to serve, and if the host is not there, what the guest would do basically. So you can set any thread as a daemon thread. You have that capability. So you can mark a thread as a daemon thread. So implicitly the Java program does it, but if you want, you can also do it. Here is the example. So a normal thread, they just call it as a set daemon is equal to true. Then that thread might become as the daemon thread. But daemon thread will might not do the regular or the normal work. So it is not supposed to do the normal work. So we are going to make monitor as a daemon thread in our example. So this is our run method. Fine. So what we are going to do is we have the if statement and then we have the else statement. So we'll just remove the else part. So else, if you will not have your this thing parenthesis, this takes care. This should run fine. Of course, we will try to run. So now we'll say the daemon thread t1.set. So now see what t1 runs and what other guys runs. So surprisingly, this was the same class, and everyone was trying to run it. But here the system checked that if it is a daemon thread, then it will do the job of service orientation based on the whatever current thread which is executing this program. Other threads will go to the else block. Just to make it more user friendly, you can put the brackets, but these were not required because for loop is supposed to be a single line statement, and anything after else, the single line statement does not need these brackets. So output would remain the same, it's just a syntactic sugar, nothing else. So we ran it again and same stuff. Now the monitor, you will see monitor has not gone into the for loop. The dumb terminal or the dumb student thread got into that. If you want to make a user thread as Daemon, it must not be started. Otherwise, it will throw illegal thread exception. So what is being tried over here is first you started it and then you are trying to convert it, which is not the case. I can also prove this guy. Little bit of reshuffling. So we have started it. So once you start it, it will be a normal thread. And once it started, then you cannot change it. Before you can do it, whatever you want. So if it's a milk, you can make a milkshake. But if milk becomes curd and then you will try to make a milkshake, it can never happen. You will get exception. That is bad. So for first, you got the exception. However, other threads got started and they were working in parallel. So your job was also getting done by the other parallel threads. So now there is a concept which is called as a thread pool. So thread pool, imagine, do not imagine a swimming pool basically. It's very different, the swimming pool and thread pool concept. So pool means a group of something. There are a lot of people or lot of resources or lot of threads or whatever. So in technology, they usually think of pool as you have so many threads which are collected together, and then on need basis program will pull one thread or take one thread, make it to work. Once the work is done, it will put it back in the pool. So pool is kind of the storage area, logical storage area. The thread pool represent a group of worker thread that are waiting for the job and reuse many times. In case of thread pool, a group of fixed size threads are created. A thread from the thread pool is pulled out and assigned a job by the service provider. After completion of the job, thread is contained in the thread pool again. Same stuff. Advantage: better performance. It saves time because there is no need to create new thread. So whenever you are trying to create any object and then it gets destroyed, garbage collected, there are some life cycle method which happens which are costly. So what they are doing is once the thread is created, they do not destroy it, they do not garbage collect it. However, they reuse it. So only the job gets changed, but the thread remains same. Job means in a thread, today thread is trying to fetch, today thread is trying to copy file A and paste it to B. Tomorrow or after some time it can copy C and paste it to D. So that is how you don't have to create new thread for this. So here is the example for the worker thread. So you just created a thread with the name worker thread and then you implemented a runnable interface, which means you have to have the run method. Inside the run method, you are trying to see, okay, what thread, what's the name of the thread, and then you're trying to do a message processing. So process message means it could be something which is retrieving data from database or whatever, which takes some time. So we are just trying to simulate that it is doing some processing and taking some time, which is about 2 seconds to just to assume. So this is a worker thread class. Now you have a thread pool example. So there is a service which is called as executor service. So instead of you calling the thread, instantiating it, and then you will be raising exception, closing exception, calling the start or whatever. You don't have to do anything. This service will do that thing for you. You just have to say how many threads you need. So let's say you have created a pool of 5 threads. Now you can make this. So they are just trying to create the worker thread. Worker thread means object of these inside it, as a dynamic way, like in a for loop. So 10 objects for the runnable will get created, and then whatever you just say executor dot execute, and then you will put it inside it. So so what will happen that ultimately there are maximum 5 threads which gets created, but first thread came here and it finished the job, whatever the job. Then next thread will take over, and first thread is, since it's done with the job once, then it will pick up another job basically. Once all the jobs are finished, then you will say executor dot shutdown. So here executor dot execute, executor dot shutdown, and until and unless it is not terminated, you are waiting here. And the reason for this is the thread can work in parallel. If you remove it, I'll just show you, give me a moment. So we will name it as worker thread. Let's say test thread pool. Let's try to name it as test pool. So you need to import it from the proper package. Okay. Sometimes the IDE behaves crazy, so it does not really allow anything to work. I need to do a control A, control X, control V. Okay, cool. So we made it work. So essentially, we are not calling thread.start or new thread or whatever. We are just running a for loop. So this will try to create 10 jobs, basically 10 runnables, and then it will pass it to the executor. And we have instructed the executor to make maximum 5 threads, fixed threads. So we don't get overloaded. Now let's try to run it. And this is how it's getting executed. It started it, and now if we try to while, so what while is doing, I'll also explain you. So it says finished all threads here. here itself. So what happened is it didn't wait for all the threads to finish, and it went to the next line without even waiting to see. So while loop is until and unless this is not terminated, the control will remain here and keep looping here so that this line does not goes next. Now this will come properly at the last. Now it came at the last. Sometime we need that once the threading job is done, then the main process, whatever the process is supposed to work, should get executed. Now we'll go to next. There is something called as the thread group. So thread group, you can create a group. It is just a management tactics that you create a thread group and then you have name the name as group A. All the other threads can be put into the group. So here is the example of thread group demo. We created a group and then whatever small threads we created, we put it inside the group, and then the group will be printed. Whatever are the number of threads which are inside that group, that will be listed. We can run this thread group demo. And I'm going to push this code in the Git repository, so it would be easy to just run it on your box once you clone this or pull it up. Thread group demo. So we have got the thread 1 which got started, thread 2, and then thread 3. Thread group name parents, it came here, and then it has given the information that thread group is the parent, and then it is giving some information of the threads whatever were there, and then it exited this process. So Java shutdown hook, this is something which is very trivial. So threads can work whenever there is a shutdown which is supposed to get happen in the runtime environment. You can invoke a small thread and that thread can do some of your jobs. That is how they call it as the shutdown hook. Somehow someone pressed Control C or wants to terminate a server, but once that thing happens you want to do some task whatever, so you say runtime. So runtime is the implicit library method API which is given by JVM. So you get the runtime and then you add a shutdown hook. As soon as the shutdown happens, you pass it a new thread or a job. We can think of my thread as a job. Job means whatever is written in the run method that will get executed. There is something to do the same thing as the anonymous class. So once we will cover the nested class lecture, that time I'll explain you what is inner class or nested class or anonymous class. How to perform a single task by multiple threads. So essentially this is the single task and there are multiple threads, and we are just say okay, start. So each thread will start and do the same thing. That is the main perform a program of performing single task by multiple thread. This is a single task. Basically this implements runnable. This is your task 1 and there are 2 threads and both of them are doing the same job. So this is like different thread are doing the different job. This is like different thread are doing the one job. passing anonymous object of this. So you are trying to pass the object of this, and then it will run that task 1, task 1. Now each thread run in a separate call stack. So there is a funda which is called as call stack. Method A calls method B, method B calls method C. So main thread does that, but you will never find that method A main method called some method in thread B which might call some method in 3. So they all work in parallel. Whatever is called, that this is the call stack. So just to understand that everything has a separate call stack, whatever are your number of threads. How to perform multiple tasks by multiple threads. So you have simple task 1, simple task 2, and then you have created two threads and you have started both of them. So the only thing is previously we had just one thread and we were calling it, so same job was done by all threads. Here you have different jobs and you are trying to do it in parallel. But this is usually this is not the way to do, because you can without thread also you can have separate methods and it can run. So there is no big deal. Big deal is when there is some repetitive task which you want that more threads can work in parallel and provide you better performance. That's how you work on that. Same example as anonymous. So we have to cover anonymous classes, and then we can understand this. Now last topic here would be the Java garbage collection. So garbage is nothing. You drink a water bottle and throw it in the computer JVM and then it collects. It's not a trash, right? So garbage internally memory creates some uh, unused space which is not useful. That's what we call it as garbage. So for better or memory efficiency, if some object is created but it's not getting used, then they want to clean it up, JVM. So it cleans it. Advantage of Java garbage collection, it makes Java memory efficient because garbage collector removes the unreferenced objects. Please note, unreferenced object means objects are there but there is no reference and they are not getting used and they are sitting ideally on memory heap. So you need to get it cleaned. So how you can you cannot forcefully usually do that. Java will do it, JVM, whenever its thread scheduler will assign it the lowest priority to clean it up. But you can suggest this guy that once your program is probably not using it, assign it to null or assign another object reference. So one object which is not required, that will be removed. And anonymous objects. So this is an anonymous object. You created an employee, but there is no object reference. So Java will clean it up because it's not used, but it's get created. Here you switched these. There were two objects which were created and assigned the object reference. But even is now pointing to E2. So both E1 and E2 are trying to pointer is pointing to this employee object in memory heap. So this became a orphan, which is not required. So it will clean. And this is another option. Just you assign it to null and then program will execute. So a thread garbage collector, it calls the finalize method before cleaning it up or taking it to garbage collection. So if you are writing a program, if you want that once it's get garbage collected, you want some lines to be executed, you can have it there. The method is defined in object. So the subclass basically can override it, and then some implementation can be given in finalize. And GC method is used to invoke the garbage collector to perform cleanup. GC is found in system and runtime classes. This is a simple program in Java wherein we can do the garbage collection. So we will just try to find it. sorry, run it. So we'll call it as garbage collection. I just named it as simple GC. So we have created two objects of this class, and we have assigned these two objects to null, and then there is a system method which is called as GC. Now we'll try to run it. Object is garbage collected, object is garbage collected. So this is the finalize method. As soon as it gets garbage collected, the message will be printed over here. Now let's see if you don't assign it to null. So if the reference was there, this was not garbage collected. Only one got garbage collected because this still has a reference S2. Yeah, so this is pretty much it for this lecture, and then we will learn about the exception handling in our next lecture.